Hi, welcome to the very first chapter in our Chem 130 course. And we use it for Chem 130A as well. Again, I'm Dr. Vincent or Dr. V, and I'm glad you're here to watch this video with me and to learn some of the materials in chapter 1. We're going to start with just the idea of matter, and then we'll move on in the second video into measurement and the numbers, calculations that we need to do with those measurements. This particular PDF document has a fancy name. I just noticed it's called Chemistry, the Science of Everyday Experience. The remaining chapters will have notes that are just kind of boring, like chapter 2, and then the name of that chapter. What you'll see is what I do for my handouts. I type up the PowerPoints first, and then I copy and paste everything onto the Word documents, or then make them into PDF files. And they'll have a lot of blanks. The theory behind this is if we were in a classroom, I would have printed out versions for you that you could then fill in the blanks as we go through. That way, my hope is you won't have to take notes on absolutely everything, but you'll also stay engaged by filling in blanks as we go through. And then later, if you miss anything, you can go back through the PowerPoint, or in this case, you could just pause the recording and fill in blanks and then resume playback for the rest of the material. This document is located on Moodle, and so is the PowerPoint. If you decide you want to download a copy of that, I recommend that before you print any PowerPoints, you check them first to see if there's particular pages you want to avoid printing out. For example, say you don't want to print out this page, then, or let's say page 2. When you go to print, you go to File and Print and set up your printer. Oops, I hit the wrong button. There we go. And you can choose how you want to print them out. If you want them full page slides rather, or you can get several to a page. Also, you can do where you get to pick which pages you print. So currently it says print all slides, but we have the choice of printing just selected slides. So you could print the current slide that you're on, or I can type in here that I want, say, page 1, and then do comma 3 through 5, comma 10 through, I don't know how many there are, 40 or something like that. And once I've done that, then I can hit print. And it will have skipped pages that maybe had a lot of extra ink or just had jokes on them, something to that effect, and you won't waste ink. I hate to leave my jokes out, so I'd prefer that you just take a quick look through before you print, if you decide to print. The other idea is that by having a black and white handout to print out instead that has all the same information on it, you can use that more for your reference. That's a hard copy, and then refer back to the colored soft copy of the PowerPoint online or on your computer. Okay, if you have any issues with downloading the files that are on Moodle, I can also provide you with links to my PowerPoint presentations directly from my Microsoft OneDrive account. So feel free to, in fact, now that I've said that out loud, I think I'm just going to always include that, because that might make it easier for some of you to view them instead of trying to download them or open up the whole thing on Moodle. When it comes time for you to do the presentations, if you're deciding to go back through on your own, one thing I recommend is that you view it as a slideshow. This option will also be available through my OneDrive account if you decide to use the browser to look at this. You click on slideshow and you can do it from current slide or from the beginning. I'm going to go ahead and go from the beginning. And that way you can click through it at your pace, and you can have the time to fill in the blanks, and it doesn't give you all of the information all at once. So you can read it, take in the information, absorb it, and then go on to the next step. I hope this gives you a bit of an introduction for how to watch the videos, use the PowerPoint presentations, and the accompanying handouts for them. Feel free to let me know if you have any questions. And now, without further ado, here we go. Chemistry, the science of everyday experience. Chemistry is the study of matter. What it's made of, meaning its composition, what it's like, its properties, and how it changes, how it transforms. Matter is anything that has mass and takes up space. And mass is simply, sometimes we're going to have the mass of something, which will basically be finding the weight of it. But anything that I can kind of touch and work with, these are the things that have mass. And volume is a fancy word for space that it takes up. Some examples of naturally occurring matter: silk, Taxol, which is an anti-cancer drug. When I worked at the research, I worked in RTI Research Triangle Institute, that's it, Research Triangle Institute, after graduate school as a postdoctoral student. We worked, that particular company is the one that created the synthetic method for making Taxol, which is used by tons of people that are recovering from cancer. And the time I was there, I was working on drugs that would help treat people who were addicted to cocaine and heroin, trying to find a substitute for the, I'm having trouble today, that drug that they give people when that's supposed to be less addictive, but it can still be addictive and cause other issues. So we were working on that. And then I also worked on a drug to help people with pain, like Vioxx. So those were based on naturally occurring products, and then we tweak them a little bit in the lab to try to make alternatives or ones that could be more easily produced. Vitamin D, that's a fantastic naturally occurring type of matter, and our bodies synthesize that from cholesterol, of all things. When we're exposed to sunlight, to ultraviolet light, it converts the cholesterol into a very healthy vitamin that most of us don't get enough of and need supplements. Something to look into with your doctors. Synthetic or human-made matter would include things like nylon, styrofoam, and ibuprofen. There are three main states of matter. There's actually a brand new one called liquid glass, but there's a couple more versions, but we're going to focus on the three big guys: solids, liquids, and gases. Solids. So these have a definite volume. If I stick them in a container, they're going to maintain their shape no matter what type of container they're in. They have particles that are really close together, and they tend to form very concrete sort of three-dimensional arrays. So maybe like a lattice or individual cubes, that sort of idea for what they're forming. Liquids, those will have a definite volume as well. I could measure them in a measuring cup, for example, and they take the shapes of their containers. So a little bit different from the solids. They have particles that are close together, but they can move past one another. So I often think of how the rocks are going to stay solid, but the water moving past them is our liquid. And imagining that sort of motion that we also would have with the individual particles in the liquid. And gases. We'll do a lot of extra work with gases later on in the semester. They have no definite shape or volume. They will expand to fill the space and assume the shape of whatever container that the gas is put in. So I can have the same, like two different amounts of gas and put them in a container, and both of them will fill that container completely. They may just not be as closely packed particles. The particles will stay as far apart as possible. They'll move around randomly. They just bump into each other or bump into the walls of the container and then bounce off and move on their way again. And again, we're going to see a lot about these in chapter 7. Physical properties. Let me move this box out of the way. We will do more on physical and chemical properties in lab. So we're going to have some overlap with this in more than one of our labs. But here's your general introduction, that physical properties can be observed or measured without changing the composition of the material. So we don't change what it's made out of. That would be things like the color, the odor, how it smells. We're going to talk some more in this chapter about density. So that will be based on the amount of material and how much space it takes up. Boiling points, the temperatures where liquids become gases, and melting points, the temperatures where solids become liquids. Solubility, how much material dissolves in a liquid. Fancy word for that, right? So when my sugar is dissolving in my tea each morning, it's a question of solubility. How much sugar can I get to dissolve in that tea? More than I should. So we'll definitely be studying more about physical properties in our labs. Physical changes. Okay. In this case, we're going to change the material without changing its composition. Really common changes, physical changes, are what we call changes in state. This is when we melt ice and go from solid water to form liquid water. We've changed from our state of matter from solid to liquid. Then, if we keep going and boil the liquid water, it forms steam, gaseous water, now it's in its gas form, or water vapor. Vapors are similar to gases. We just use that term if we have something that is going from a liquid to a gas, then we consider it a vapor. Not a big deal for you to know the difference. Vapors and gases, that change is a physical change. The water molecules will remain the same. And let me take just a moment. We'll talk about this further later in the chapter, but what you're seeing in all of these images that have a red sphere and then 2 white spheres attached, the water, you may already know, is H2O. The water molecules are made up of 1 oxygen atom, and that's the red sphere, and 2 hydrogen atoms. Those are the 2 white spheres. So whenever you see this combination, it's going to pop up in a lot of images in the presentations in your textbook. It's just showing a molecule of water, a particle of water. And we have it tightly packed in a 3D arrangement in the solids. They're more jumbled together, but still pretty closely packed in our liquids. And then my water molecules are spread way out. But notice in every single image, it's 1 red sphere, 2 white spheres attached. These are just physical changes. And now that we've talked about atoms for a moment, you'll see this geeky shirt again, but today's geeky shirt is that you should never trust an atom. They make up everything. So those sneaky little liars making up everything, those are our atoms. Let's talk about the opposite of physical properties, chemical properties. These determine how one substance can be changed into another substance. That chemical change is better known as a chemical reaction. That changes one substance into another substance. In a chemical reaction, the bonds or connections are broken and rearranged. Pretty much anything burning is going to be a chemical reaction. Metabolizing an apple for energy. Your metabolism, I know lots of times you're probably thinking about eating foods and having it broken down into different parts, building blocks maybe for other kinds of molecules in your body and for energy. But technically, metabolism is all the chemical reactions in your body, both breaking things down and building new things in your body. That sort of idea of breaking bigger parts into smaller parts and smaller parts being joined together into bigger parts, chemical changes. Oxygen and hydrogen combining to form water, that's a chemical reaction. It's not water going from solid to liquid. This time we're actually creating the oxygen and hydrogen into the water molecules. That's a chemical change. And the properties are so different. We'll talk about that too. It's pretty cool. Our pure substances. We've been talking about the properties of our matters. Let's do just a little bit of defining. Pure substances are things that are made up of just one component. So water, for example, is just made up of the component of one oxygen atom attached to two hydrogen atoms. That contained unit, that's one component in water. And a pure substance has a constant composition, regardless of how much sample there is and where the sample came from. Sugar is sugar, whether I get it in a little packet on the restaurant, remember restaurants going in and eating at them? Yes. So the restaurant table will have a pack of sugar. The composition of that sugar is exactly the same as the big bags that we get from stores and so forth. And it doesn't matter where it came from. It can come from Hawaii or from somewhere else that sugar is grown. The other neat things about pure substances, they can't be broken down into other pure substances by a physical change. The only way for me to separate the hydrogen atoms from the oxygen atom in water is to do some sort of chemical change, or technically we could do stuff with electricity, but it won't be able to say, we can't filter it or boil it or melt it and make those parts of the water molecules break apart. No physical changes for those. Table sugar, 12 carbon atoms, 22 hydrogen atoms, 11 oxygen atoms, put together in a very certain way creates our sugar, and there will be no way of physically separating those pieces that must be separated via chemical changes. So, sugar and water are both pure substances. In a mixture, we get to put our pure substances together. We'll have more than one component in a mixture. They can have varying compositions. So they can be a combination of solids, liquids, gases, and it can be made up of just individual elements like just oxygen or just hydrogen, then mixed together. Or it could be where I take, in this case, we have more than one group of atoms that have been joined together already. These mixtures can be separated into components by a physical change. So in this case, when I have sugar dissolved in water, well, we can evaporate the water, collect it in another container, and the sugar will remain behind. Now I have physically separated those two components of the mixture. I didn't have to do any sort of chemical reaction to do that. Elements versus compounds. I used that term a second ago when I talked about oxygen and hydrogen being elements. They are pure substances that can't even be broken down by a chemical change. The water, the sugar, we could break those into individual elements. That's it. In terms of chemical changes, I can't break them down any further. They have created these massive, massive instruments, I guess you would say, that can break open these individual element atoms of those elements, and we can see inside of them, but we don't have a way to do that chemically. That is an example. Aluminum metal is an example of another element that you would be familiar with. A compound is a pure substance that's formed by chemically joining two or more elements. And later we're going to watch how that chemical joining of the elements creates completely different properties. For example, I'll show you the video of this later, but with sodium, that element of sodium, that thing catches on fire if it gets wet. If it's exposed to water, it can spark and all kinds of stuff. And chlorine, the element chlorine, is a toxic yellowish green gas. But when you put them together and a little bit of spark to get the romance going, they will react chemically together and form table salt, which is a lot less poisonous and doesn't catch on fire that we can have on our tables safely. Completely different properties from their original elements that chemically joined to form that pure substance of the sodium chloride compound. This is where I would ask if you have any questions. Maybe you're writing down some questions for me that you're going to ask during our live sessions, or you can, if it's a really burning question that's keeping you from going any further, I want you to go ahead and email me and I'll give you a quick response. Or you may be deciding that you want to use one of the chemistry tutor sessions that should be available through ACC for free. Hopefully this really is figure 1.6, page 8. Some of my slides may still refer to an earlier version of the book, but we should have a bit of a flow chart. We start with the matter. Anything that has mass and volume takes up space. We can decide if it's a pure substance or a mixture based on whether or not the components in it can be separated by a physical process. If I can filter them or evaporate one of them, something to that effect, or maybe one freezes first and then I could remove the liquid away from it, that means it's a mixture. If I can't do a physical process, then it's a pure substance. Then check and see, could I do a reaction with it that will break it down into simpler substances, maybe into other elements or other smaller compounds? Well, then that is a compound. If I can't break it down any further by chemical reactions, then it is an element. Look at that. We are done with the first part of this presentation. Now we start doing the math stuff. And don't freak out if you're worried about numbers. Numbers they stress me out a bit too. So as we start going between things that have numbers and words with them, we'll start with the words and then plug in the numbers. That'll help us maybe not freak out quite as much. And those of you that are good with math, congratulations. You'll be able to get through this part quickly. The assignments on Connect, there is one based on what we just went through with the ideas of solids, liquids, and gases, and chemical versus physical properties and changes, and with identifying elements versus compounds versus mixtures. So go ahead and try those out. There's only a few questions. It'll build some confidence with doing your homework assignments. And then you can come back for the second video that will be longer, that will have to do with measurements and units and things like that. Let me know if you have any questions.